Hey guys, so this presentation was originally held in Utrecht in the Netherlands. However, the recording of the audio then dropped out somehow, and Side Effects asked me to re-record the whole thing, which I happily did. However, I felt like it wasn't doing a good job at portraying the atmosphere that was in Utrecht. So I decided to create a small audio track in order to accompany this whole talk. Yeah, thank you. Let's get started. So, after Winston Churchill left the stage, the audience was raving as soon as they heard the announcement of the next talk, which was MOPs, Motion Graphics Operators for Houdini. Well, thank you guys. Thanks for the warm welcome. Oh, thank you guys. Thanks. The transform modifier might be the most essential modifier there is in MOPs. What I set up here is this animated. So this is what can happen when you try to come up with something new when you're trying to develop something that makes arcane topics seem a little less daunting. With that, hello and goedemiddag, I'm Moritz. You might know me as the less beardy part of Entagma, and I'll be talking about our attempt to make things accessible. And my usual question here is, who just started using Houdini? Please raise your hands. And who has used Houdini for a longer time now? Raise your hands. Okay, have you ever tried to get an artist or designer or colleague into using Houdini? Yeah? So, have you noticed how hard it can be starting out in Houdini, or a certain resilience against starting to use Houdini for a design task? Well, this talk is about learning things and about making things more accessible when you're starting out. And it's also about what trying to develop an asset library for Houdini taught me about my own learning process. So this talk is about providing motion graphics tools for Houdini, aka MOPs. More precisely, this talk is split into two chapters: how to use them, or things to do, versus how to build them, or things not to do. So here's a quick intro into what is MOPs. Hey guys, let me introduce to you Henry, better known under his nickname Toadstorm. You might know him from his blog. He's doing lots of Maya and especially Houdini content there. He also has exquisite taste in cat content, but he has also very interesting pieces on matrix math.
Hi from California.
Last year I've been discussing with several people that it would be neat to have some sort of either library or toolkit to make it easier to do motion graphics in Houdini.
A lot of people have complained over the past years about how difficult it is to do simple things like rotate a bunch of cubes. So I decided it couldn't be that hard to build a toolkit for it, and I was wrong, but I still went forward with it anyways, and Moritz found out about it and showed me the tools that he was working on and asked if I didn't want to join forces.
So what we did during the past weeks and months is, in somewhat secrecy, we've been working on this. We decided to call it MOPs.
MOPs is short for motion operators, and it sounds ridiculous, but so do the other Houdini contexts, so it seemed appropriate.
It has a nice side effect that in Germany it means pug, so the logo of course has to look like this. So one goal for this was to make it more accessible for the average motion graphics animator or designer to do motion graphics and create motion graphics inside of Houdini with the help of simplified setups, of simplified nodes, and a more accessible workflow.
So the other half of our approach is that we wanted to make the entire toolkit accessible also to seasoned Houdini users. So people who are familiar with Houdini's attribute workflows and with packed primitives. We have a suite of low-level TD tools that are intended to make it easy for experienced users to build their own modifiers. So if we don't have something included in the toolkit, it's pretty straightforward to build it yourself.
So I think we both are very excited to get this out to you guys. See your reactions, get your feedback. We are very excited to see where this all takes us.
I'm really looking forward to seeing what the motion graphics community can do with this.
So the goal that we had in mind when developing MOPs, when trying to come up with the concept first, was kind of this. Something easily created in other tools and also perfectly doable in Houdini, just a bit tedious to set up when you are starting out using Houdini, and this was rendered by Emmanuel here. So, to illustrate our point here, I collected some quotes on using Houdini, and those problems are well expressed in those few lines here that you might hear quite frequently when you are in the process of moving parts of your studio pipeline over to Houdini. The one that I got in the beginning by artists was very often, Houdini is too complicated for the stuff I'm trying to achieve. Then, after working with them a few days, few weeks, This is what you hear most of the time. I'm constantly rebuilding those few basic setups that I'm gonna reuse all over the place. And finally, sentences that are still uttered by me until this very day is, where did that file go? Why didn't I document this stuff? And what all of those comments embody is a struggle in adapting to certain behaviors that Houdini encourages. And also a struggle to cope with the necessary background knowledge to use Houdini efficiently. So our goals for MOPs have been these. Make it easy to get into. As an artist transitioning from another software package, you should be able to create the kinds of setups that we quickly mentioned without doing much research. Especially no research into math, such as coordinate systems or matrices or quaternions, or research into Houdini specifics, like primitive intrinsics. Also, we wanted to make it fast, because what good is a tool if it can't work on big data sets? Because frankly, some of the more impressive setups that you do in design and motion graphics, they just depend on the scale. We also wanted to make it adaptable. It should be versatile, more universal toolkit. Because in our rationale, the more universally you can use something, the more users will adapt to it more quickly, rather than to a very specific tool. Also, our goal was to try to document it, at least try to, because although a tool can be designed in a very accessible way, we believe that a huge part into providing the user with something usable is documenting it properly and getting her or him started quickly. So those were our goals, and the way we tried to achieve them were this. So easy to get started. And we tried to make this whole toolkit very accessible by relying on a very simple principle. So basically, what you're doing when working with MOPs is you're setting one float value. You're manipulating one single value. And the way you do it works like this. First, you create instances with these nodes. So that's their icon. They just create instances, fast copies of your geometry. Then you write a falloff value onto those instances, just a single value, ranging from 0 to 1. 0 meaning this copy won't be influenced at all, and 1, this copy will be influenced fully. And finally, you are modifying instances using what we called modifiers and using the falloff value that you just wrote. So for example, 0 means do not modify this copy, 1 means do fully modify this copy. So we try to stick to this extremely simple principle wherever possible. Performance-wise, we decided to use pack primitives over real geometry and instances over real geometry in order to give the whole thing a performance boost. And the way that pack primitives works is a bit like this. On the one hand, you can see here, this is the standard full geometry. In our case, a simple cube, 8 points, 6 faces, 24 vertices. On the other hand, we see an instance of this cube. That means somewhere in your RAM, in your memory, exists this cube geometry, 8 points. And then we have another point that just points to this cube, that just references it. And admittedly, for this single cube, it makes no sense doing it like this, because you end up with another point. So instead of 8 points, you have 9 points now, and you also need to reference this and set attributes. So it doesn't make really sense. However, when you look at cases in which you have multiple copies, like these here, 6 copies, it starts to get a certain speed advantage. Because on the one side, you have these 6 geometries. So 6 times 8 points, 48 points. On the other side, you have this 8 points of the cube and those 6 references pointing to it. So you end up with 6 plus 8, 14 points, versus the 48 points that you had previously. And this advantage in speed and memory even increases with the amount of copies that you create, with the amount of instances that you create. However, the mean part to this is when it comes to orienting your instances. And we are used to Euler angles for that. But when it comes to instances, you'd rather use this neat function in Vex and this one here. This is a matrix, 3x3 or 4x4 matrix. Or if you don't want to do that, you can use that, orient, which is a quaternion. And now you might ask yourself, what is this? A quaternion, a matrix, an Euler, Well, Euler, that's the name of Leonhard Euler, Swiss mathematician. And he came up with this very intuitive way of describing an orientation, a rotation. So Euler angles work like a gimbal. You have one rotational value along each axis, x, y, and z, just ranging from 0 to 360 degrees, if we do it in degrees. So, cool, you might say, let's rotate around this one axis, and let's rotate further, and we are screwed. Because now what we did is we aligned 2 of our rotational axes exactly the same way. So we are losing the ability to fully orient whatever we'd like to orient now, because our 2 axes are perfectly aligned now. They would rotate around the very same axis. Enter quaternions. And I'm not going to go into full detail what quaternions are and how they are mathematically described. For now, let's just say that quaternions are 4-dimensional numbers that can be used to describe rotations. And this is cool because quaternions don't gimbal lock when you interpolate them. And a rotation is just a multiplication of quaternions. That's actually a mistake down there. Should read multiplication. Yeah, wow, that was easy. Well, kind of. The good part about this is we took care of it. You can just stick to your Euler angles. We internally convert to quaternions or matrices and also take care that while we're doing stuff such as advection, we don't get flipping. So much for the performance and tech background on this. Again, we tried to make using packed primitives and instances as painless as possible with abstracting away all that nasty stuff like dealing with quaternions and matrix math. And at the same time keeping it quick due to their very memory efficient nature. So let's talk about adaptability. So we wanted to make this useful for as many people as possible. And of course, the beginner will stick to mainly using our high-level tools. However, the seasoned TD might want to use these. These are some nodes we created to be able to actually easily deal with all this packed primitive fun, all the while being a bit more low-level and more basic than our main MOPs nodes, in order to provide TDs with a possibility to actually build on this toolkit. And as this is free and open source, we are hoping that as many people as possible will participate this and will contribute to this, and we were going to see a few community addition to this. That will be really neat. Also, this is called MOPs Alpha for a reason, so if you want to check this out, expect bugs, and please just report them to us, and please feature ideas, report them. We are extremely eager to see what you guys have to say on this. So let's go to documentation. Yes, we do have documentation. On the one hand, on our webpage, we have video tutorials. So I think we have tutorials for every high-level node. The TD nodes are still lacking. I'll have to do that next week. But for the main nodes, we do have video tutorials for them. And also, I'm extremely proud of this one. We do have built-in Houdini help cards. And Henry was extremely motivational when it came to them. Because, to be frank, writing documentary is not the most fun part in the world. However, we pulled through with it. So if you go to our nodes and just hit the question marks on top of the nodes here, you will be taken to a help page that describes the parameters of that node and what it actually does. So the most common question at this point we get is, when can we get our hands on this? And the answer I got for you is now. It's been live since yesterday evening. Very exciting. And probably the most difficult part about all this is, how do I get this? And I'll try to make this as painless as possible. So what you do is you go to motionoperators.com, our website, where you can also find video tutorials and links to our social media and a bit about ourselves. And when you click on download there, you will be taken to this page here, which you can also access directly, which since the beginning of this week is now part of Microsoft, github.com/toadstorm/mops. And there, all you have to do is click on that green button there and then download a zip file of MOPs, and that'll download all the files necessary for MOPs. So once that you downloaded that, you unzip it and you just copy the main folder that's been hiding in the zip somewhere that you like. In this case, I just copied it to Houdini's 16.5 documents folders, which has the nice benefit that it's right above the houdini.env file, which we'll have to edit in order to be able to access MOPs in Houdini as soon as it loads. So you'll open up the houdini.env file, and all you have to do is add those 2 lines in your Houdini env, and then just make sure that you copied the right installation path, you excluded the OTLs folder in the path, you exchanged the paths backwards / forward slashes, you added the right variable, you make sure you spelled Houdini OTL scan path correctly, you added a $sign in front of that variable when using it, you added the OTLs folder back now, and finally check if you added a semicolon, @ symbol, and / to the OTL path. Wow, that was easy. Well, to be frank, it's not that hard as I put it there, and we also created a tutorial that deals with installing it, and we are looking into creating a proper installer. Until now, you'll have to change those few lines of codes, but they are properly documented on our website. So let's get to the funnier part. How do you actually use this? And I'll try to make this as painless as possible as well. So I brought you 3 examples. Here's example 1, the standard bread and butter motion graphic setup in Houdini. So what you do, you start out with a cube, scale it flat along one axis, so you have this plate-like thingy here, and then drop down a MOPs instancer, and there you can add instance geometry. So we got support for multiple geometries here, which we'll iterate through, so if you want several different pieces of geometry to be instanced, no problem. However, in this case, we just want to drag the single box in here, and then we end up with default behavior of our instancer, which is just a linear copy of the whole thing. So let's just modify the distribution of that and make it behave like a grid, like so, and then scale this apart so that we now have each of those single cubes that you see here is a single instance. Okay, created instances. Now let's add the falloff value to it. The main tool for that might be the shape falloff, which allows you to create this kind of ramped fall off in a geometrical way. So not only do we have support for linear, but also for creating a spherical fall off, a box-like fall off, and a toroidal fall off. So after I created this linear fall off here, let's just animate this by setting a few keyframes here and at the end, and also adding a bit of noise. So with each of our fall off nodes, we have the ability to add noise into the fall off, to just break it up a bit and just make the fall off a bit more interesting and the resulting animation a bit more interesting. So now that I set this up, I can hit play and I see this fall off just going through all of my instances here. And they go from white, which is 1, to blue, which is 0 in our case. However, I don't want that. I want them to go from blue, that means 0, to 1 white. So I'm going to drop down a remap fall off here, which just works like curves and levels in any image editing application you have. And I can use that to tweak my fall off values very precisely. And in here, I will just use it to invert it. So now my fall off goes from 0, which is blue, to 1, which is white. Okay, now let's finally do something with the copies. Let's modify those instances. And again, your main modifier here is the transform modifier, which just simply allows you to rotate, scale, or move your instances. So I wire this up, and before I will just set up a rotation around the x-axis 180 degrees. So just flip it once, then wire this up and highlight it and hit play. So you can see now those planes flipping while my fall off runs through them. Okay. This is a bit linear, so let's add some secondary motion, and for that you could, for example, use one of my favorite modifiers, the spring modifier, which is just a physical implementation of Hooke's laws of spring. Wire this up, and my hint for you is to not springify position, rotation, or scale directly, but springify the fall off itself. So what we're going to do is wire this in between the fall off and the modifier, and just springify this single value that drives how strongly each copy is affected. And then let's have a look at it from the side and add a bit of vertical translation to the whole thing when transforming it. And also get rid of the color and just make it black, a dark black. And then when we hit play, we can see this behavior. So just this transform modifier, but with a springified version of the fall off, so it wiggles. And this is just a 5-node setup. So that's been kind of your bread and butter setup. Let's have a look at another one that shows off some more intricate tools that we built. So again, we start off pretty similarly by just dropping down a box, dropping down an instancer, linking up that box into the instancer and setting it up to behave like a grid. Then it gets interesting. Again, we drop down our shape fall off, wire this in, and this time just set it up to behave spherically, so we get this kind of circle of activated copies in here. And then let's have a look at this one here. This is called move along spline, and it took us a while to figure out. And what this modifier does, it takes in a second input and it wants a spline there. So let's drop down a curve and just from a side view, just quickly draw a curve in there. Wire this up, and what the move along spline does is it looks at this incoming spline and just moves those copies along the spline. In the simple mode, it just looks at the closest point on the spline and just takes the tangent of that spline and moves the copies along that tangent. So basically in the direction of the closest point of the spline, which is there and which is nice. And I'm not sure, maybe someone has a use for it. But what I like more about this thing is the advection or interpolation modes. And the user interface changed slightly since I recorded this, but the functionality is still all there. So what I want to do is I want to use this to move my copies and advect them along the spline while creating a point trail behind them. And then what I want to do is I want to delete my instances and only keep the points that I just created, like this. So I'll end up with just this trails. And now what I want to do is I want to use those points as the origin for another set of trails that I'm going to create by advecting them through curl noise with the help of the curl modifier. Append that, and also I have a mode here that generates those trails. In this case, I've set it to generate trail lines. And all I'm doing here is tweaking my fall off, scaling it a bit so that down here where the lines originate, the curl noise is really short, and up here it's getting longer and longer. Again, just tweaking this with the help of a remap fall off here. And then if I want to render this, of course, what I could do is use Mantra's built-in hair rendering or Redshifts hair rendering to generate splines out of this. However, in some cases I would like to have real geometry. And for that, we were kind of missing a few features in Houdini's polywire or wireframe subs. So that's why we decided to create the MOPs sweep spline, which I drop down here, and it takes 2 inputs. On the one hand, the backbone. This is the shape the overall shape of the geometry of the spline that we're going to create, and then also the cross section. So if you cut across the spline, what's it look like? In my case, I'm going to use a circle, which I just set up to be this regular triangle, and then wire it in. And when you highlight the node, you can see when zooming in, we generated those triangular shaped sweep splines. Also, you might notice they are a bit twisty and they scale over their length. And you can dial that in by dropping down on the one hand the scale and also the rotation/twist settings here. And they allow you on the one hand to enter concrete values here, like for the overall scale, maximum scale, minimum scale. But they also allow you to tweak that scale with the help of these ramps here. So you have very fine control over how the scale and also the twist behaves over the length of the spline. This one just shows the twist adjustment. So let's dial down the overall twist a bit and we end up with something like this. And you also have the possibility to drive where the sweep spline begins and where it ends to animate this. And you can see we also automatically added caps here, so the splines are closed. And of course, everything comes with UV coordinates for easy texturing. So once you zoom out, you end up with something like this, and with a little bit of tweaking and some nice materials and rendering this with a bit of GI, you end up with this, our preview image for MOPs. Finally, our example 3 shows some of the more in-depth TD-oriented tools. So in this example, I'm setting up your standard Voronoi fracture, fracturing the standard test geometry, the pig head. So what if I want to turn these into MOPs instances now? Well, we have two nodes for that. On the one hand, the MOPs convert, so each piece is now a separate MOPs instance. However, currently I still have a problem because their local coordinate systems are not set up correctly. So would I move them upwards now, they would just move upwards along the y-axis because they still have the same coordinate system as the world coordinates. What I'd like, however, is their y direction to point in the direction of the surface normal of the pig at their respective position. So for that, we created the MOPs reorient node, which on the one hand takes in those instances, on the other hand takes in a mesh from which it derives the axis systems. And then it's back to your normal MOPs workflow, writing down a fall-off onto those instances and then using the transform modifier to transform them, move them around, scale them, rotate them, whatever. And you have an easy animation in which your fractured pig pieces just disappear. Wow, that was easy. I hope you finally agree to me that at least we're getting at a point where things get easier, if not easy. So this is how you use MOPs, what they are, where you get them. The second part of this, and I just want to go quickly over this, is lessons that I learned until now. So you want to build those assets, and how hard can it be? And before coming here, I asked Henry if there's something that he thought would be valuable for you guys to know when it comes to developing assets. And this was his answer here. And I blanked this out because this was just some niceties about the overall development process. But also he's saying that math is hard and editable assets are the devil. So I think that was just his mood at this point. Those were just those main issues that he had to deal with. What I drew out of this, and not necessarily out of the facts or the hard facts of this conversation, but the conversation alone. Development is a surprisingly social process. I'm not sure what I expected when I started, but I expected it to be a more mathematical, mechanical, logical way, because we are dealing with machines and we are programming machines. However, we are interacting with humans and human beings, and we are no machines after all. And this helps a lot to have someone who is co-developing with you, to bounce off ideas, to check if something makes sense, or just to vent, or just someone to listen to you complaining about how terrible Git is or how terrible everything is, and it might not be that terrible after all. Also, I asked Henry if he still remembered our initial schedule, which I think we tried to come up in January or February. And he said, I think we figured we'd have the whole thing in the bag by March. Well, if you look at the development process, and this is just a perceived version of it, this might not be true, but it feels a bit like that. So coming up with an algorithm and implementing an algorithm actually is not the major part of it. However, if you're looking at development, this might be the only thing that you see. The stuff that you try to put on the side is the border cases, the UI, the UX, the framework integration, and of course the documentation, the website, the setting up the forum, SSL server, getting domains, creating tutorials, etc., etc., etc. So when it comes to estimating your progress or estimating your schedule, this formula has proven really helpful, and Manuel actually came up with it. As a decent rule of thumb, take your initial estimate and make this the worst case estimate. So initially we thought, okay, worst case 4 to 6 weeks, about a month. Now multiply this by 3, end up with 3 months in our case, and add 1 4 months. So from January, February, this brings us to end of May beginning of June, which is where we are now. And I don't know why, but this rule has really proven helpful over and over, not necessarily with development projects, as well as standard client projects and standard advertising projects. This thing has been really helpful. Times 3 plus 1. Then another thing that I discovered, I hate to admit it, but tidiness is not just for patterns. It makes development easier as well. And this, although it's kind of profound, just recently hit me, I think last week, and I'm currently working with another extremely talented developer, and I'm trying to get into a new programming language, one that's not really documented until now, and I'm just trying to figure out what was going wrong in my setup that I tried to create, some physical solver here, and I was getting grumpy, so at a certain point I got the developer to sit down with me and go through my code. And while he was looking at this, he was getting increasingly grumpy as well, because I had a long piece of script there. And what he did is he went in there, deleted all comments I had in there, then renamed every single variable I had in there from something like const A, const B to initial constant or initial setting, final setting, hardness, stuff like that, so that they really made sense and that you could read them and decipher them without having the need to read any comments. And after he did that, on the one hand, my code shrunk to about a third of its original size. Everything made sense. Everything was readable without actually having comments in there. And I discovered that I was missing a plus somewhere. So it was just him, without having any idea of the physics I was trying to implement there, just going through the structure of my code and just cleaning it up. And only thus could I discover the mistake that I made in there, just omitting a mathematical symbol. So I hate to admit it, but I'm not tidy yet. I'm working on it. When you're opening up some of the MOPs nodes, you will see they are anything but tidy. But I think as we implement fixes and new features, I'm trying to revisit them, at least for my part. I think Henry's part is a bit more cleaned up than mine, but I think I'll have to get in there and rework those a bit. And finally, what always surprises me is how enthusiasm creates enthusiasm. So when we were starting out, we just tried to keep the low profile and told some of the guys about the stuff we are trying to do, and it's amazing. The feedback that we got from them, the sheer, enthusiasm that they had about this project. And this is a thing particularly special about the Houdini community. Everyone is so eager to actually progress with this thing, and everyone is so eager to make working with Houdini easier and discover new things, and is so helpful when it comes to providing insights and providing maybe code or help on any of those topics. So yeah, I guess what I want to say here, the community support that we've seen is really amazing and something special. With that, I want to thank you. Again, go to motionoperators.com if you want to download and test this stuff out, and please make sure to give us feedback, bugs report, feature requests, anything. Thanks, guys.